We have decent knowledge of half adder and full adder. In this lecture we are going to obtain full adder by using the half adder. The only difference between the half adder and full adder is carry input. In case of half adder, we do not accept the carry from the previous sum, whereas in case of full adder, we do accept the carry from the previous sum. So we have one more input along with the numbers that we want to add, that is Cin, representing the input carry from the previous sum. We have the sum and carry output. The output part remains the same for half and full adder, and in case of half adder, the sum is given as A XOR B, and in case of full adder, the sum is given as A XOR B XOR C in the input carry from the previous sum. And the carry output for half adder is A and B, and the carry output for full adder is A and B, or B and C in, or A and C in. This carry output we can also write as A and B, or C in A XOR B. To obtain the circuit, we are going to use this expression. So how many half adders we require to obtain the full adder? We need two half adders to obtain one full adder. So let's make two half adders quickly. This is the first half adder, and I will copy this and paste it again. So these are the two half adders. I will name them half adder 1, half adder 2. The input to the first half adder is definitely A, B, because these are the two numbers that we want to add. And let's say the output of the first half adder is S1, right? And the output of the second half adder is S2. The carry output of the first half adder is CO1, and the carry output of the second half adder is CO2. So this is what we have, and we want to obtain these two expressions by using these two half adder. So let's start with it. If I talk about the output of the first half adder, that is S1, it is equal to A XOR B, right? And we want A XOR B XOR C in. So we have to introduce another input, that is C in, but we cannot give C in to this half adder because we cannot accept carry from the previous sum, but we can definitely give C in to this half adder as one of the input, and I will use the output of the first half adder as the second input to this half adder number 2. So what about S2? This is A XOR B and this is C in. So the S2 is going to be A XOR B XOR C in, and this is nothing but the sum of the full adder. So we have obtained the sum, and now we will move to the carry output for the full adder. Carry output is A and B. If I talk about CO1, that is the output carry of the first half adder, this is A and B, right? And if I talk about the carry output of the second half adder, it is C in and A XOR B, because A XOR B is the first input and C in is the second input, and we have to add both the inputs to obtain the carry output. So the only thing that we need to do is to OR these two carry outputs. So we will use one OR gate, two input OR gate, and we will have two inputs A and B, and the second input will be C in and A XOR B. So the output of this OR gate is going to be A and B, or C in and A XOR B, which is nothing but the carry output of the full adder. So in this way you can obtain the full adder by using two half adders, and we can also prove it. That it is nothing but A and B, or B and C in, or A and C in. So let's prove it. A and B, or C in A XOR B equals to A and B, or C in A XOR B can be written as A B complement or A complement B. By using the distributive law, we have A B complement C in or A complement B C in. Let's take A common from the first two min terms, and we will have A in bracket B or B complement C in, A complement B C in. We already know X or X complement Y is equal to X or Y. We will neglect this part. In the same way, we will neglect B complement and we will have A B or C in, and rest part will remain same. We will again use the distributive law and we will open this bracket, A and B or A and C in or A complement B C in. Right. In the next step, I will take C in common from the last two terms. So we have A and B, or in bracket I am left with A or A complement B. C in we have taken common, A and B. Again, by using this law, distributive law, we will have A or B C in. That's all. We are done. We have the expression that we needed, A and C in or B and C in. So this is how you can prove that this expression is same as this expression, and this expression is easy to remember and also easy to obtain the circuit. If you would have used this expression, then definitely it would be very difficult to realize the circuit. In order to realize the circuit, you remember this expression and you can easily have your full adder by using the two half adders. So this is all for this presentation. In the next presentation, we will discuss 4-bit parallel adder using full adder. So see you in the next one.